Hi, everybody. Welcome to the Climate and Community Resilience series, Lessons from the Soil. We're so excited that you could join us online. This is not how we anticipated delivering this information, but in times like this, we all need to learn to adapt. And so we're working hard on doing that. So bear with us as we also learn to use this technology. We're going to start off with a bit of an opening to make sure everybody knows what's going on. This entire series is being recorded, so anyone who is on this meeting right now needs to know that we are recording this meeting. You can turn off your videos, you can turn off your mics, and that's very helpful for us if you do that. If you have any questions about how to do that, open up the chat on the bottom of your screen, and you can send a message to everyone, and our hosts will help you to handle anything that you're having trouble with in terms of video or muting or communicating or figuring out this new platform. You may have a setting turned on your computer if you're on your computer where you can hit your space bar, which will mute you. So choose your settings as you feel comfortable. If you're having trouble with anything at all, just send us a message in the chat and we'll help you take care of that as best as we're able to do. The chat goes to everybody, so anything you put into the chat, everyone will be able to see. So just be aware of that. You are muted on entry. We can also mute you. So please stay muted so that it doesn't add distractions into the meeting. Your video is turned off. When you enter, we can also turn yours off, and you can do that as well, and we encourage you to do that. You can rename yourself if you prefer not to have your name shown on the screen. If you need help on how to do that, then send us a chat. So I'm hearing now that folks are having trouble hearing me. And I'm not sure if that's, are other folks having trouble hearing me? Chris Wood, I can see your face. Can you hear me? Okay, I'm going to keep going. Sorry if you're having trouble hearing me. It could be your own volume. So maybe check out your own settings there. We're going to provide an opportunity for questions later on in this series. And so we're asking that as we're doing our presentations or our opening or anything, if you have questions you would like to ask us, please put those in the chat. Start your comment with a question mark so that the people who are viewing and reviewing the chats, our co-hosts, will be able to differentiate those kinds of questions. And if you have a specific question for someone individually like myself or Lauren, our two speakers for today, please put our names first so that we can be sure to address those properly. Our host may be combining like questions as we go through our presentation so that we can be most efficient with our answers. Once we go through a question and answer round, we are intending to go into Zoom breakout rooms where we can have a little bit more of a personal, so to speak, conversation with one another. And again, this is something we're just trying out for the first time. How do we build community and talk to each other in this format? I think we can figure out how to do it. So we're going to give that a shot today. When you go into the breakout rooms later on, and we'll remind you of this as we get there, you will be automatically muted and the host of that break room will be able to unmute you. And I think that's about it for our initial openings. Please keep your chat box open during the presentation so that you can be aware. An example of how to ask a question. So I'm going to ask a question in the chat. Let's just pretend, and I'm going to type in question mark, cat. I want to know this of you. I think that's a pretty good example. If you have any questions about that, please let us know in the chat. Okay, and at this point, I'm going to turn the next phase of our opening over to Lauren Weston, our co-host for today.
So I'm going to be reading a land acknowledgement that was provided by John and Donna Moody of the Winter Center for Indigenous Traditions. And just so you all know, this acknowledgement is also posted on our webpage at the Vermont Healthy Soils Coalition website. So please, please do go download that land acknowledgement and use it in future work. So, when Indigenous peoples in the Americas travel to other Indigenous nation homelands, it's a common courtesy since ancient times to acknowledge the Indigenous nation and peoples whose homeland we are gathering on. For the purposes of this series, being broadcast and watched from the Wobetek on the ancient grounds of the Wobetek Odanak, so that was the White River Village, in Indakana, which means our land, we are gathering in the middle of this ancient nation homeland, which includes Vermont, New Hampshire, northern Massachusetts, western Maine, and southern Quebec. The Alnobak, the people, as they are called in Alnobiwi, which is the Abenaki language, have also been called the Wobanakiak, people of the East or Dawnland, or the Abenaki, since ancient times, by Indigenous relatives in the East and Indigenous peoples as far away as the Hopi and the Diné, or Navajo, all the way to the present-day Alaska and Tierra del Fuego in South America. Today, we are convening online from the sovereign homeland of the Abenaki Nation and people. Abenaki traditions speak clearly of being created here in the beginning. Though archaeologists and linguists, as recently as the last 40 years, stated that the Abenaki and all of their Algonquin language group relations from California and High Plateau to the Plains, Great Lakes, Hudson Bay to the Maritimes, and down to Virginia, are no more than 1,500 years old. And some more recently have stated that the Abenaki may be related to Indigenous peoples who are documented here for 9,000 years, a date that keeps moving back given the major Abenaki site recently documented in Keene, New Hampshire, which is dated to the mid 13,000 years before present. The Abenaki peoples themselves, along with many of their cousins in the Northeast, state unequivocally that we have always been here and we will always be here. From ancient times down to 1760, the Abenaki Nation, which included numerous villages and thousands of extended families, was an independent native nation centered in their homeland, recognized by all other native nations and the British, French, Dutch, and other European colonizers. Though some parts of the homeland in the seacoast of New Hampshire and Maine, southern Vermont and New Hampshire, as well as northern Massachusetts, were shared with the encroaching English colonists from the 1630s on, most of the original homeland has never been sold or given away. In the American Revolution, George Washington, the Marquis de Lafayette, Jacob Bailey, Timothy Bedell, Moses Hazen, and many other leaders of the American resistance agreed with the Abenaki and their cousins, the Penobscot and the Passamaquoddy of Maine, that they would retain their villages and homeland in exchange for helping in the defense of the northern frontier against the British. The ancient villages of Missisquoi in northwestern Vermont and the Coasac or the Coas in the upper Connecticut River were both explicitly acknowledged as Abenaki villages of long standing, which would remain in Abenaki hands in perpetuity. The Penobscot and Passamaquoddy nations retained 3 villages in Maine after the Revolution, after a tremendous 30-year struggle down to 1800. In Abenaki country, the word of the new American colonials was not kept. So the Abenaki Nation was largely driven underground in the 1760 to 1800 period. The people have remained in every town and watershed in the homeland, right down to the present day. In the 1970s, the Abenaki Nation of Missisquoi and the Coasac Abenaki of the Coasac Traditional Band of the Sovereign Abenaki Nation stood up in northwestern Vermont and the upper Connecticut River Valley. They formed the Abenaki Nation Coalition with many Abenaki extended families and communities to protect and care for the people and the homeland, as well as to facilitate the protection of Abenaki burial grounds and sacred sites, and to return Abenaki burials, grave goods, and sacred items back for reburial. In 2008, the Bureau of Indian Affairs Federal Acknowledgement Project rejected the Abenaki Nation of Missisquoi petition for federal recognition, with extensive involvement of the Vermont Attorney General's office. In 2011 and 2012, the Vermont legislature acknowledged 4 Abenaki communities, including the Abenaki Nation of Missisquoi, the Elnu tribe, the Nulhegan tribe, and the Coasec Band of the Cause. The original Coasec traditional band of the sovereign Abenaki Nation, which is still based in Thetford, Vermont, was blocked from being acknowledged by the Vermont legislature in 2016 and 3 of the 4 new tribes. Chief Nathan Pirro of this group will be our speaker at event number 2. Please tune in. In addition to the Abenaki Nation of the New Hampshire and the Coasec Band of the Pennacook Abenaki people, are long-term Abenaki groups which are also not state or federally recognized. There are hundreds of Abenaki extended families in this area and the wider nation homeland and beyond that are still here. In Canada, there are 2 Abenaki Nation communities at Odanak and Wolanak, which both are federally recognized in Canada as First Nations. We want to acknowledge the ancient Abenaki Nation people. We are aware that countless newcomer families in this area and the wider region were given indigenous seeds and plants, shown the ways of Sogalikan, which is maple sugaring, introduced to many crucial technologies and ways of living, from canoe, toboggan, snowshoe, and basket making, to ways of farming, fishing, trapping, and living, along with caring for the land, waters, and air in a good way, which are still widely practiced in the Abenaki homeland. We hope we will learn to better care for the land and waters here in partnership with the many Abenaki Nation peoples in a respectful way. Thank you. And here is Kat back with you.
Thanks, Lauren Weston, for that beautiful opening, and thanks to John and Donna Moody from the Winter Center for Indigenous Traditions for helping us to craft that and put it together for this important series. It's a really critical thing that we honor before we get going on anything. So a little bit more of the welcome to anyone else who has joined since we started this webinar. Just a little reminder that if you have any questions, please put those in the chat. You can find the chat down at the bottom of your screen, and we have quite a few co-hosts and hosts that are helping us to manage that chat and make sure that everyone's technical questions get answered, and also as we get into our presentation, that we can put all of your questions in the queue for our presenters. I really am so excited to be here at the Climate and Community Resilience Lessons from the Soil series, and we could not have possibly have done this without our organizational group. These are the people that have been meeting all winter to try and put this together for you. We have huge thanks to the Hanover Food Co-op, Co-op food stores in Hanover, New Hampshire, Vital Communities, BALE, which is Building a Local Economy, located in South Royalton, the White River Watershed, Vermont Healthy Soils Coalition, Upper Valley Food Co-op, Extinction Rebellion, Upper Valley, and Grow More, Waste Less. So individuals from those organizations, including myself and Lauren Weston, have been really trying to put together this program for you for quite a while, and we're so excited that we're able to adapt and transition to an online format. So bear with us as we try to work our way through that. So again, thanks so much to all of our organizational sponsors, and be sure to thank them yourself when you go to visit their stores or businesses, donate to their organizations, or see us on the street in a self-distance sort of way. I also want to thank our sponsors, which we have quite a number of sponsors that have contributed to be able to make this possible, to make sure that all of our speakers are paid for their time and their expertise. We also want to let you know that in addition to all of these sponsors, Chelsea Green, who's listed on this slide, and I just want to give a shout out: No Fuss, Sustainable Woodstock, Cedar Circle, Rural Vermont, Soil for Climate, Vermont Compost Company, UVM, Center for Sustainable Agriculture, Clean Yield Assets, Upper Valley Land Trust, White River Natural Resources Conservation District. You're all amazing. And Chelsea Green has, in addition to sponsoring this event, has also provided a discount code for anyone who is taking this series. And anyone who sees it online within a certain amount of time, I presume, will be able to use a discount code for online orders only through Chelsea Green for 35% discount off all of their books, which is an incredible, incredible offer. So be sure to take advantage of that. The code is here on the screen. You can also find that on the Vermont Healthy Soils Coalition website. Additionally, on the Vermont Healthy Soils Coalition website, there is a donate button. So anyone who can donate to this series, please click that button and help us raise more money to offset the costs of this series. And we'd love to be able to continue doing these series, especially as we're all locked up in our homes. At event 6, which we're planning in May, and hopefully we'll be able to have an outside in-person gathering on a farm. Stay tuned. As things change with our current world situation, we will be updating the Vermont Healthy Soils Coalition web page, our Facebook page, and all the other places that you've been reading about this event with all of the updates as they come. If we can start to gather in person, that is certainly our preference. So stay tuned for that. At that 6th event, we really want to have a raffle. So anyone who shows up will get raffle tickets, and we'll be raffling off 4 books that are donated by Chelsea Green. Those are, just to get you excited about them, From What Is to What If by Rob Hopkins, Surviving the Future by Sean Chamberlain and David Fleming, Cows Save the Planet by Judith Swartz, and Farming on the Wild Side by John and Nancy Hayden. So the timing and format for our event today, to give you an idea of what to expect, we're getting close to being done with the opening and context, which we feel like is a really important part of this series. When we're through with the opening context, we're going to switch over to content. The presentations by Lauren Weston and myself will each go for about a half an hour. After that, we'll have some time to ask presenters questions. If you have questions that come up during the presentations or after, please type those in the chat. Start your question with a question mark, and then who it's addressed to, then write your question. That will make it much easier for our co-hosts to organize those questions in a timely format so that we can answer those. After the Q&A period, we really want to break into breakout rooms. We like to do a go-round where we can hear from everyone who's joining this webinar. And in order to do that and accommodate the number of people that we have, we will be breaking into rooms so that everyone can have a chance to talk, and then we'll reconvene for a very short closing to say goodbye and thank you at the very end. We have a series of upcoming events. So this is the first of a series of 6 events. On your screen right now are listed all of the other events as they are planned with their rearranged times and online format, given the pandemic that we are all in now. Again, please stay tuned to our postings. If you've registered for the event, you'll get emails. If you did not register, just check our Facebook page, Vermont Healthy Soils Coalition website, and you can still register for the event to make sure that you get those emails as changes do happen. If we are able to meet outside in person or in a building in person, we certainly would favor that. All information and everything in this presentation is being recorded right now. All of those presentations, the entire thing, including the breakout rooms, will be accessible by recording link on the VHSE website and our YouTube channel. We'll make sure that you get those links, do not worry, so that you can view this again or you can share them with your friends. We absolutely want you to do that. We're working on live streaming for future events. As we all are learning more about technology, we may be able to increase the capacity of our audience as we move forward, so stay tuned for that. And I think that's all I have to say. I'm going to turn it over to Lauren, who's going to give us a bit of an introduction to this entire series framework.
Thanks, Kat. So I'm also going to just briefly introduce myself here. Hi, everybody. It was messaged to me that nobody knew who was talking. So I'm going to say hello for now, and then I'm going to turn my video back off, and you guys will be able to meet Kat the next time she talks as well. So I'm going to turn myself off now that you've all seen me. Hello. Hope you're all doing okay. All right. So shifting gears to talking about the content of this series. This series seeks to explore the idea that what is good for the soil is good for our communities. By this, we mean that healthy, vibrant, biodiverse, functioning landscapes can teach and remind us as humans how to connect, collaborate, and appreciate the value of every aspect of our world. We mean that we can follow the general guidance of the soil health principles that Kat will talk about later to work to reconnect and build a different future. This means that we want to have living plants growing and sending roots out into the ground to cycle nutrients and provide the foundation for our societies. We want to maximize diversity in all of its forms. We want to question disturbance in terms of what is causing it and what the consequences are. We want to consider critically what is covering the surface of the earth. Is it plants that help cycle nutrients, or is it something else that breaks connections and cycles? We want to help to provide the conditions for all life to thrive, humans, plants, animals, microbes, everything. And we want to revisit our relationship to the water cycle and how we view this life-giving resource. There are a few different versions of these ideas are the soil health principles and the soul health principles that Kat will dive into. We just wanted to also be clear that there are countless other versions and models that people work with to frame how to care for the soil and ourselves. These particular frameworks of the soil health principles are being presented to you because they're what we built this particular series around. We structured this series such that there would be time at the end of each event for every attendee to speak and share with the group, and we kept some of that. Originally, we had built in a considerable amount of time for people to connect with each other in person and review resources provided by various organizations. Due to the limitations of webinars, we're unable to provide those opportunities, but we do have resources posted on the Vermont Healthy Soils Coalition website that we hope you will explore and utilize in the future. We also hope that connections that are made during these webinars will continue and will inspire people to meet up in person when it is safe to do so. Today, we hope that you will learn something new and have your curiosity and imagination sparked. We hope that you will make a new friend, learn about a new organization, or have your world completely turned on its head. And we hope that you will strengthen the relationships and deepen understanding that you are already bringing with you today. The goal of these events is to realize the knowledge and resources available within the community of the Upper Valley, and to use that to build a just future. There will be presenters providing some content and new ideas, but everyone on this webinar and beyond is a critical part of this community. We are trying to work against the typical expert audience dynamic often experienced at events like these, because we all have something to contribute that someone else needs. However, we also acknowledge the limitations of this webinar format, and we're aiming to find some middle ground on this particular topic. We are all dependent on each other and the Earth's systems. We all bring with us models of how we believe the world works, and we ask that you remain open to having those models changed and expanded. We are working towards thinking about connections and relationships, working in whole systems. Though critically important, we do not want to get stuck on the parts of the elephant in the room that Kat will dive into a bit more later. We want to bring these issues into context to deepen our discussion and understandings and to find new solutions. Lastly, if you are someone who speaks a lot during the breakout rooms, consider trying out listening more and vice versa. If you are someone who likes to be told what to do, consider taking initiative and trying something new. If you are someone who gets stuck on barriers and why you can't do something, consider what it would take to do it anyway. If you are someone who looks for leadership, consider becoming a leader. And if you are someone, know that you matter and we all value you as part of the community. Please do whatever you need to do to feel comfortable during this webinar. These events are for you. Please get up and go take care of your crying child or make a phone call or use the restroom. We will have a couple breaks though. But please take care of yourself during this webinar. All of the video recordings, again, will be posted online, so you can come back to them later. And now, excuse me, over to Kat.
Okay, hi everybody. We're getting really close here. I just want to go over a few community agreements before we get into our presentations. Those are up on the screen now. You should be able to see them. So the world is changing, and we wrote that before the pandemic. Oppression exists. I think we're all familiar with that, and if we're not, we should become familiar with that. Everything, not just everyone, has the right to live. Everyone deserves to be heard. We bring with us our working models of the world. We're open to adjusting those. We all speak only from our own lived experiences and worldviews, and we should be accepting of others who are doing the same. We're all willing to learn. We're all willing to listen. And if you have other community agreements that you would like us to adhere to and you would like to see us bring out into future webinars, please type those in the chat so that we can incorporate those into future events. Your participation, your listening is so important to us. Thank you. And we're going to turn it right over now to Lauren Weston, who is going to give us our first presentation, The Foundations of Energy and Matter.
Hello again. You guys will get sick of me pretty soon. So Kat, Buxton, and I are your presenters today in this first workshop of the series. We were on the planning team for the series, and we felt that we could frame it well since we knew who else would be presenting and what they would be bringing to the sessions. I'm going to be presenting on some of the science of climate change, but I also want to be very clear that climate change is not just a scientific issue. It is a justice issue. It is a social, economic, and cultural issue that cannot truly be addressed through just more technology. We must, as a society, look critically at the systems we use that have gotten us here. With that in mind, we chose speakers for the series who could speak towards lots of different aspects of climate and community resilience. Because of my particular background and the trust that I have that you will all come back to the next events to hear from those speakers, I am focusing today on the sciencey side of things. I've been working to better understand the Earth and its systems so that I can attempt to fathom some of the impacts that my choices and the choices of my community are having on the whole world. The content that I'm presenting is some of what I've learned and felt might be useful to share with you all. I look forward to the new questions that come out of today and to continuing these discussions. All right, let's get started with the foundations of energy and matter and how they relate to climate change. So, climate is the long-term average of weather. Weather is the way the atmosphere is behaving. I apologize for how that is set up on the screen. Weather includes the components such as temperature, pressure, wind, humidity, precipitation, and cloudiness. Therefore, climate change is changes from the long-term average of those components over an area, be it a town, a watershed, a bioregion, a continent, the entire world, or some other area. When we talk about climate change, sometimes we talk about global warming, and that is one piece of this. Global warming means that the average overall temperature of the world on an annual basis is increasing due to an amplification of the greenhouse effect. We'll get into more of that soon. Other aspects of climate change involve disrupted energy distribution patterns. Air and water move energy around throughout the atmosphere, and when those movements change, climate changes. When we talk about these ideas, we are talking about changes that fundamentally alter life as we know it on the planet. These changes impact habitat ranges and resource availability. We are experiencing mass migrations, mass extinctions, wars, economic collapses, and many other consequences of those changes. So let's try to understand some of why this is happening. You'll be seeing this slide a lot today. It'll serve as a table of contents to guide us through the presentation. What it's showing is a clearer summary of the previous slide, indicating that climate change is the amplification of the greenhouse effect and changes in energy distribution. In order to understand those ideas, we need to understand the fundamentals of matter and energy. We will dive into energy distribution by discussing the modes of energy transfer, which are radiation, convection and conduction, and latent heat. So let's start with matter. Matter is the stuff that makes up Earth's systems. It's every subatomic particle that makes up every atom, that makes up every molecule, that makes up everything. Air, soil, oceans, buildings, humans, plants, dogs, cats, everything. Humans decided to name atoms based on how many protons are in the nucleus. So an atom with 1 proton is called hydrogen. With 6 protons is called carbon. And an atom with 8 protons is called oxygen, and so forth and so on. Around the nucleus are electrons that we will talk a little bit more about later when we get into radiation. So where did all of this matter come from? There are many understandings of how the Earth and its matter came to be. This includes various creation stories from indigenous cultures and religions around the world. For today, current Western scientific theory tells us that matter came from the Big Bang 13.7 billion years ago. In terms of Earth, it left a cloud of cold dust particles that about 4.6 billion years ago was disturbed and collapsed under the force of gravity to form our solar system, including our sun, the Earth, and the other planets that orbit our sun. Just a quick side note here, there are at least 200 billion suns in our galaxy, the Milky Way, and there are millions of other galaxies in the universe, just for some perspective. Today, the Earth functions almost completely as an isolated system in terms of matter. This means that there isn't any new matter coming from outer space, barring the occasional asteroid, and we aren't losing matter to outer space. This means that matter cycles through Earth's systems. It doesn't come and go from outer space, it just changes form and moves between Earth's own systems. This is a critical idea for understanding that the carbon and water cycles that influence our climate. Again, more on this later. Now, moving over to the fundamentals of energy. Energy is what is required for matter to change. Now, unlike for matter, the Earth is not isolated in terms of energy. There's a constant flow of energy in from the sun and a constant flow of energy out of Earth's systems to outer space. Therefore, we are often concerned less with energy cycles and more with energy balances on a global scale, meaning that we want to know that the amount of energy coming in is the same as the energy going out. Otherwise, we are gaining or losing energy, and that means heating up or cooling down on a global scale. This can lead to global warming. The modes of energy transfer are radiation, conduction, convection, and latent heat. Those modes are represented on this diagram here, which I'm sure you've all seen in one form or another before. This is the Earth's energy budget diagram from NASA that I think is really helpful for understanding these concepts because it breaks them down into pieces. What I think is really critical to understand here is that in any discussion about energy on Earth, there are 3 systems or layers that we are thinking about. We're thinking about outer space, what's coming in from it, which is largely just from the sun, and what's going out into it. We're also thinking about the atmosphere, this region around the surface of the Earth that extends away. By one estimate from NASA in 2017, the atmosphere extends up to 6,200 miles away from sea level. Most of the mass of the atmosphere, 75 to 80%, is in the troposphere, which is the layer that we live in, the first 4 to 12 miles, depending on latitude and season. This is also where our weather occurs. And then lastly, we're thinking about the surface of the Earth, meaning the land and oceans, surfaces, meaning buildings and trees, farms, mountains, glaciers. Everything that isn't floating in the atmosphere is the surface of the Earth. Here's just one more way to visualize this idea, making sure that we keep in mind that there are 3 different layers that are interacting with each other. Now, getting to how energy moves between these 3 layers, let's start with radiation. As you can see here, radiation is the major mode of energy transfer when we're talking about Earth's energy balance. All of those boxes represent a specific component of radiative exchange. The other 2 on the far side of the diagram will be discussed later. So, what is radiation? Well, I'm so glad you asked. It is radiant energy. It is transferred by photons, which are discrete bundles of electromagnetic energy that travel at the speed of light and behave both as particles and waves. All things with the temperature above absolute 0 radiate energy constantly. Radiation is still a subject of intense study, and it can be really hard to wrap our heads around. So for us today, we're curious about the ways that radiation interacts with matter. On a molecular level, radiation can be absorbed, emitted, or scattered in different directions. The arrangement of the electrons and nuclei within the molecules determines what will happen to a photon of radiation of a given wavelength. This is the crux of the greenhouse effect. We'll talk about that a little bit more later. When radiation interacts with the material on a larger scale, we talk about what percent is absorbed, reflected, and transmitted. Together, these 3 components add up to 100%. Absorption increases the internal energy of the matter by exciting electrons and impacting chemical bonds. This can increase temperatures because temperature, after all, is just the average kinetic motion energy of the molecules. Reflection is when the matter scatters the radiation back in the direction it came from. On a global scale, for solar radiation, we call this albedo. Transmission is the scattering of the radiation along its original trajectory forward. Transmission leads to something called windows, where the majority of radiation of a certain wavelength passes through. In Earth's clear atmosphere, we have these windows around wavelengths of radiation in the visible light range from the sun, where the rainbow is shown on the diagram, between 8 and 14 microns from the Earth, which is a little bit further over. And then we also have it in the range of radio waves. So let's talk about radiation in the 3 layers that we were talking about earlier: outer space, the atmosphere, and the surface of the Earth. In outer space, the sun is sending radiation away from it in all directions. Our Earth happens to be in the pathway of some of that radiation, which is great for us. The Earth's atmosphere interacts with the radiation from the sun in all the ways that I mentioned before. Some of this radiation gets absorbed by the atmosphere and the Earth's surface, causing them to warm up. They warm up, but they don't get as hot as the sun. Because of this temperature difference, the average temperature of the sun is about 10,000 degrees Fahrenheit, and the average temperature of the Earth is about 58 degrees Fahrenheit. The wavelength and the total amount of radiation coming from these 2 entities is very different. That's what's being shown on the chart in the upper corner. The sun gives off more radiation than the Earth. Think about the area under the curve as the total amount. Going back to calculus for you guys. And the sun gives off most of its radiation in the wavelength range from 0.1 to about 3 microns, whereas the Earth gives off most of its radiation in the range from 8 to 20 microns and longer. For this reason, we generally refer to the radiation from the sun, or solar radiation, as shortwave, and the radiation from the Earth, also called terrestrial radiation, as longwave. Focusing for a moment on shortwave radiation from the sun, let's detour into photosynthesis. The wavelength of radiation from the sun that gets through the atmosphere and reaches the Earth's surface is largely in the visible light range. We call it visible because the human eye has evolved to be able to differentiate the wavelengths in this range and has associated them with different colors in our brain that we call red, blue, green, etc. Luckily, plants have also evolved to be able to use this range of wavelengths to their advantage. The chlorophyll molecules and chloroplasts absorb visible light strongly in the blue and red wavelength bands, and less so in the green band. That's what's reflected for our eyes to see. The absorbed radiation causes electrons in the chlorophyll to get excited, and that triggers a chain of reactions that produces sugars or carbohydrates that get used by plants to build their cells, and they also get sent out through roots to feed soil life underground. Kat will talk a little bit more about that later. It is really interesting to think about how fundamental radiation is for life on Earth. Along that same line of thinking, the fact that different molecules interact with certain wavelengths differently is also key to making our planet habitable by maintaining a temperature suitable for life. With this, I am referring to the greenhouse effect. Without the greenhouse effect, the average temperature of the Earth would be near 0 degrees Fahrenheit. The greenhouse effect is a result of the fact that the gases in the atmosphere transmit shortwave radiation through to heat the Earth, but some of them scatter long-wave radiation coming from the Earth in all directions, including back down towards Earth. That's the reflection back to us. This effectively traps some of the long-wave radiation and keeps the energy from being released to outer space. Most of the gases in the atmosphere don't interact with long-wave radiation in this way. Only greenhouse gases do. Depending on the location and time of day, the atmosphere is made up of 0 to 4% water vapor, which is the most abundant greenhouse gas by far. And then about 0.1% of the atmosphere is made up of a combination of other greenhouse gases, like carbon dioxide, methane, nitrous oxides, fluorinated carbons, and ozone. These gas molecules are well suited to perform this task, to keep the planet habitable. However, getting back to climate change, the carbon dioxide argument often made is that humans have disrupted the carbon cycle to the point that more carbon dioxide molecules are in the atmosphere than ever before. This, therefore, amplifies the greenhouse effect and changes the Earth's energy balance, causing the Earth to warm. A few nuances here that I find really critical. Humans have increased the amount of carbon dioxide in the atmosphere, but thinking back to matter in Earth's systems from earlier, the actual total amount of carbon on Earth hasn't changed. We've just changed the way that the carbon cycles. Carbon that used to be in the ground as fossil fuels, in vegetation for most of the year as biomass, and in soils as organic matter, is now in the atmosphere because of our power plants, engines, and agricultural and land management practices. Another detail is that the carbon dioxide levels in the atmosphere are not just constantly increasing every day. I know that we all hear that the levels are up to 415 parts per million, when a safe level might be 350. But just keep in mind that those numbers are the annual averages of the CO2 levels in the atmosphere. Over the course of the year, carbon dioxide levels in the atmosphere go down during the time period when it is summer in the northern hemisphere. This is because the majority of the terrestrial landmass on Earth is in that northern hemisphere, and summer is the growing season for most of our species of vegetation, including what we farm for food. This means that photosynthesis on planet Earth is working its hardest to take some of the carbon dioxide from the atmosphere and transform it into biomass. And one more detail, just to add to it. The oceans, in addition to the atmosphere, have been carrying a large portion of the carbon that is no longer found in terrestrial ecosystems. Earth's oceans have absorbed about 31% of our carbon emissions since the Industrial Revolution. This means that if the world does figure out a way to reduce the concentration of carbon in the atmosphere, the carbon stored in the ocean will begin to be released back into the atmosphere, lengthening the timeline to reestablish a carbon cycle. So that's the carbon cycle. Here's the water cycle, which is another major thing that we've messed with. Don't forget that water vapor is the most abundant greenhouse gas, and so changes to the water cycle also strongly impact the greenhouse effect. Just a few of the ways that we've altered the water cycle include removing vegetation, which disrupts the soil-plant atmosphere continuum that moves water through transpiration, the extraction of water resources from underground aquifers to bring that water into our fields, channelizing our rivers and stormwater paths to move water off the land and out of cities into the oceans as quickly as possible, paving and covering soil, which reduces infiltration, and we've also added particles to the atmosphere that change the way that clouds form and precipitate. We'll come back to the water cycle soon to dig in a bit more, but I'm bringing it up here because people often forget about the water vapor component of the greenhouse effect, which deals directly with radiation. Okay, so deep breath. That was our overview into radiation. It's a big, complex mode of energy transfer that drives a lot of the energy balance on Earth. But it's not the only mode of energy transfer. Let's dive into these other ones. Conduction and convection involve the movement of sensible heat, or heat that, when moved to a new substance, causes the temperature of that substance to increase. You can sense or feel it. Conduction is the transfer of heat by direct contact. On a molecular scale, when heat energy moves from molecule to molecule as a result of collisions from vibrations. Like in the image when your hand touches a hot pan. My apologies. Convection is the transfer of heat by the mass movement of a fluid. A fluid is just a liquid or a gas. And here we're talking about billions of molecules scale. The circulation of water in a pot of boiling water demonstrates convection. In the Earth's energy balance, conduction and convection move energy between the Earth's surface and the atmosphere. For this piece, solar radiation comes through the atmosphere and heats the surface of the Earth. Then the molecules in the air immediately above the surface of the Earth get heated by conduction. The air molecules are touching the warm ground molecules. Those air molecules then move as an air parcel away from the surface of the Earth because they are warm and they want to cool off by spreading out and getting away from the heat source. This motion forces other air molecules down toward the surface of the Earth, and this cyclical motion is known as convection. Because the sun's radiation is not evenly distributed across the surface of the Earth due to the Earth's rotation, albedo, and the angle of incidence of the sun, the radiation, conduction, and convection patterns are different at different locations, which drive pressure gradients, wind, and storms, things we call weather patterns. Now, maybe you'll have noticed that in this upper diagram shows latent heat release too. We'll address that now. So again, latent heat is just another mode of energy transfer. Excuse me. It involves the water cycle and clouds, and it is the last piece of our energy budget. Latent heat is hidden heat energy that changes a substance from one phase to another without changing the temperature of the substance. Some examples of phase change where latent heat is involved include changing from a solid to a liquid, known as melting, or from a liquid to a gas, known as vaporization. At pressures and temperatures commonly found on Earth, groups of water molecules can regularly be found in all three phases: ice, liquid water, and water vapor. At the surface of the Earth, water can evaporate and transpire through vaporization, meaning that a liquid water molecule can absorb enough energy from the substances around it to be able to be released from the molecular bonds with other water molecules and enter into the atmosphere with other gas molecules, like nitrogen and oxygen. This can cause localized cooling. The water vapor molecule holds onto that energy until it condenses, at which point it is given off to the matter it condenses on as translational energy in chemical bonds. This new movement increases the temperature of the matter that the water vapor condensed on. When that happens in a cloud, it increases the temperature of the cloud and thus increases the amount of radiation given off by that cloud. Latent heat transfer emphasizes even more just how important the water cycle is to energy dynamics on Earth. In addition to being a greenhouse gas and moving around latent heat, water in the form of clouds impacts albedo and radiation transfers. Oceans absorb CO2, glaciers melt with increasing temperatures, contributing to positive heating feedbacks. Sea levels rise because more water is in the ocean and the oceans are warmer and expanding. It's all very complicated and interconnected. It requires anyone who is thinking about changing climates to think about whole systems and complex interactions. And thinking in this way is necessary because it's the only way that we can truly understand what's going on. From a science perspective, we've now gone through each of these components of the Earth's energy budget, and hopefully there's a greater collective understanding of what we mean scientifically when we say climate change, of what's really going on with the long-term averages of temperature, pressure, wind, humidity, precipitation, and cloudiness, and how it is fundamentally altering life as we know it. So now what? Some people want to use this information to engineer new technologies to control these systems. Others want to figure out how to replicate pieces of these systems so that we can live on other planets. Even still, others have decided the Earth will balance herself out without our intervention. And others anticipate the end of the human species. I think that by understanding these ideas, we can try to undo some of the damage that we've caused and make better decisions. Luckily, Kat Buxton, who will be speaking next, is here to share some of her ideas about how to do that by managing our land and systems differently. And on that note, I am going to stop talking, and I think we have time for about everybody, if they want to go up and stretch. There's about 3 minutes until Kat will start her presentation at 4:30. So if you have any questions for me, please type them into the chat with a question mark and my name in front of it, and we'll be back in about 3 minutes. Thank you.
So just in case you folks are not on the chat, the WW2 or WM2 question from Deb Hawthorne was answered by Lauren as watts per square meter. And we'll be taking more questions after my presentation. My name is Kat Buxton, and I think I know many of you, but I'm not sure I know all of you because it's hard to know who's even on here with this interesting format. I think it's been a couple of minutes, and so I'm going to go ahead and get started. And actually, the first thing I wanted to share was not this show, but a little video. Many of you may have seen the flour and bread video. This exercise was designed by Dee Dee Pursehouse and a high school science teacher at Hartford High. And it's now been done all around the world. And I love to start my presentations with this. So I'm going to go ahead and just hit play. We're looking at two landscapes here. On the red plate, this is a degraded landscape. It's flour as a stand-in for a degraded landscape, which is dirt, sand, silt, and clay, broken up rocks. On the green plate is bread, and it's a stand-in for a healthy landscape. It's sand, silt, clay, and biology. Super important. Let's see what happens when we rain on these landscapes. Pouring water into a rain cloud, of course, and the rain cloud is causing erosion. The rain is causing erosion. We see some runoff. There appears to be flooding. The color of that water indicates that the soil itself, or the landscape, is now a part of the water system. We have dry places all over the landscape, but yet there's flooding. This seems to be flooding and drought at the same time. If we were a plant in this landscape and there was a drought and places did not get water, it would be dry at the bottom. So let's see. We find a totally dry plate on the bottom. So if we're a plant in this landscape, our roots would not have just gotten a drink. We would be thirsty. Flooding, drought in the same place, poor water quality. If you were farming or gardening in this landscape or adding any type of household chemicals to this landscape, those would now be in the waterway. Let's see what happens when we rain on a healthy landscape, on the bread. The water is infiltrating into the sponge of the soil. It's soaking in like a sponge. Those pore spaces that hold the bread out are happening because yeast is the magic ingredient in bread, which is the biology in bread. That's what makes air spaces those organisms breathe. Those pores are held together in landscapes by the goose glues, snots, and slimes that are produced by biological soil organisms that live all throughout the soil landscape. Let's see what happens when we rain twice as much on this landscape, since we didn't see any flooding from the first rainstorm. These pore spaces make up about half of the space of soil, and they are where the air is in soil. It's where water can infiltrate into soil, and that air and water, along with photosynthesis and the sugars made by plants, sustain microbial life in the soil. So twice the amount of water, and we still have no flooding in this landscape. I'm going to pour a little more because I'm really trying to reach saturation here. Saturation will happen when we start to see water flow out from the bottom of this landscape, indicating that the water is going through the soil to the base layer. Soil is a filter, healthy soil. Biological organisms and chemical interactions with those organisms in the soil, in these pore spaces, in the sponge, actually clean water. If you had to live in these landscapes, would you choose the flour or the bread if you were a farmer? If you were growing plants of any kind, you would likely choose the bread. The bread is wet all the way through. We have full saturation. If these landscapes were out in hot, sunny conditions for days after this rainstorm, this one would evaporate and get covered with a hard, crusty surface, would not take in water the next time it rained. This one would get a little stale on the outside, so to speak, because it's bread, and down in the middle you would still have some moisture, so organisms and plants in this landscape would still be able to get a drink. If you had to build a house in one of these landscapes, you would likely choose the bread. Your house here might be in the waterway. If you had to get water from natural sources in one of these landscapes, you would likely choose the bread because you might be able to find it after it rained and you would want to drink it, as opposed to this right after a rainstorm. That was flour and bread. I hope that translated well for you. And just in case you're wondering, the brown layer in the middle of the bread was not peanut butter. It was actually a little bit of an end heel that I didn't know was in there when I made the video. But c'est la vie. We'll make them better in the future. That is one of my favorite activities. I do that with kids and people of all ages when I start my presentations, because it makes a great reference to go back to. So I am Kat Buxton. I run a business called Grow More, Waste Less. I'm the co-founder of the Vermont Healthy Soils Coalition and a board member of the Soil Carbon Coalition. I wear a lot of hats in our community, and I'm so proud to be a member of this community. I'm excited to share with you this relatively new presentation principles feed practice, building the soil sponge in our backyards and communities to meet climate change, manage extremes, and to stay well. Humans, we are something else. So I'm not going to read my slides to you because I assume that you're reading those as well, but I can say that soil is incredibly important. And the more I learn about it, the more I realize that so much of what we need now and what we need in our future, and not just us, but every other being on the planet, is greatly determined by the health of our soil. And we get to decide what kind of impact we are going to have on landscapes as humans. The world has over 60 years of topsoil left, according to the United Nations in 2014, and that has been reiterated in more recent reports by the UN. We are losing topsoil at an amazing rate. This photo that we're seeing on the screen is a picture that was taken by my colleague Peter Donovan from the Soil Carbon Coalition. Excuse me. Okay, I'm going to turn my video off because I just got a message that my internet connection is not great. So no more video, and I'm going to keep on going, except I wanted to go backwards. Sorry. The world has 60 years of topsoil left, and that we're going to be in trouble if that if we continue our current rate of action with the way that we manage our soil. As this slide shows, that according to the Soybean and Corn Digest of 2017, for every bushel of corn that we harvest in the United States, grown just like this in this picture taken by Peter Donovan, in just 2018, where the corn is planted right up to the waterway, every bushel of corn that is harvested, we lose a bushel of soil. And you can almost see that happening in this still photo. It's as if the Dust Bowl never happened. We're planting right up to our waterways again. And I want to say that this is not the fault of farmers. This is not the fault of people managing land. This is a part of our economic system, and we can change that. Globally, soil degradation is astronomical. The red areas on this map are indicating very degraded soil, and in some cases, those are places that are now deserts that used to be biodiverse ecosystems. This is very real, and this is very connected to climate change. Lauren's presentation was wonderful and really mapped out some of those systems that are managing our planet as we understand them. And what we're learning is that soil and biomass are incredibly important holds for carbon and water in our ecosystem. And we broke it, but we can fix it. And it's happening all over, the fixing, and that's what gives me hope. This particular map is from the Soil Carbon Coalition.org website. You can go on there and find a lot of these different maps, very fascinating, and some little movies that you can play to show the change in time over the crop insurance indemnities that have been given out in the last 15 years. This particular map in 2014 really stood out to me because it's showing places where farmers, landowners have gotten crop insurance indemnities for both excessive moisture and drought in the same place at the same time. This is showing us that what's happening globally is also happening here. Just like the flower on the plate, we have flooding and drought in the same place at the same time, and that is likely due to a lack of biological diversity in our soil. Soil is alive. This slide is showing us, it's a pretty famous slide, you may have seen it before, an estimated $800 million in infrastructure damage caused by Tropical Storm Irene. The brown that we're seeing in Long Island Sound there is Vermont's dirt roads and our topsoil. That's where a lot of it went, and we can't get that back. That $800 million in infrastructure damage does not include 1 penny for soil health or water quality. These are some pictures from around Vermont, some from Tropical Storm Irene. I'm sure you've seen many of them. They're all over the internet, and many of us experience these visuals ourselves in our own communities. And it's not just Tropical Storm Irene. Every time we get rain now, it's intense, and it's hard to manage. The bottom right picture there is showing our school gardens at Thetford Elementary School, and about 8 foot below that center part where the water is going down is a drain. So our entire schoolyard flooded in just a rainstorm. This was not even predicted to be a big rainstorm. This is the kind of water management that we have ahead of us. According to the University of Vermont Climate Change and Agriculture Program, headed up by Joshua Faulkner, you can go to the website. The link is there on the bottom right of the slide to show you all of this research and more. And I'm not going to leave the slide up long enough for you to be able to read it, but all of the slides from this presentation will be available on the Vermont Healthy Soils Coalition website, in addition to the recorded webinar that we're having right now. On the top right in bullet points are the summary of the things that we can expect, what we've seen, what we can expect: wetter springs, more common, very heavy rains, longer summer dry spells and droughts. I know farmers that are watering in September when they've never watered in September before. More farmers are having to invest in irrigation equipment to be able to manage the extremes in hydration and drought. And that's a big cost, and those things are often plastic, which is also another concern for us. We're having warmer winters. This one is exemplary for that. Here we are on March 22nd. There's hardly any snow on the ground, and I'd really like to be outside. And we're having longer growing seasons, but they're not really predictable or reliable, which is actually making it so that we're taking more risks with our seeds. And sometimes we're really winning and getting nice red peppers late in the fall because we had a late spring. But sometimes we're also getting rot and diseases. So the soil health principles are something that we can all embody to be able to manage our relationship with the land better than we have in the past. These principles are something that I've been employing in all scales of gardening that I do, farming, etc. The first four, the top four, 1, 2, 3, and 4, are designed by the Natural Resources Conservation District, or Service rather, originally called the Soil Conservation Service after the Dust Bowl, and now called the Natural Resources Conservation Service. They're all really good. The fifth one was coined by one of my mentors and idols, Gabe Brown, a rancher from North Dakota. I highly recommend checking out his book, Dirt to Soil. And slow and sink the water, number 6. If you follow all 5 principles, that will happen, but it's so important to change the way that we think about managing water that I like to add it to my slide of the soil health principles. And we're going to go over these as quickly as I can. This slide has a lot of words on it, and again, I'm not going to read them to you, and they will be available for future viewing. But one thing I really like to point out is the idea that soil organic matter, which is everything dead, everything partly living, everything that's falling from trees and plants and heading into the soil, along with all the bugs and the roots and the microbes, all of those things are soil organic matter. And when we have soil organic matter in our soil, it can hold 18 times its weight in water and recycle nutrients for plants to use. If you've ever seen my presentations before, you know that I get really excited about microbes. So I just got to say it. 1 teaspoon of soil, or maybe you could say 1 tablespoon, I might have that wrong, can contain over 1 billion organisms, 75,000 species of bacteria, 10,000 protozoa, scores of nematodes. All of those are microorganisms, and a mile of fungal hyphae filaments. Those are the teeny tiny little hairs of fungus that you need a microscope to be able to see. A mile in a tablespoon. It's just incredible. And that is literally what is holding our landscapes together. That little pine sapling picture on the bottom right is showing you the pine root system of a baby pine tree. And most of what you're seeing there is actually the mycorrhizal fungus. And that is what helps to connect all sorts of plants together so that they can talk to each other. I'm sure you've heard at this point that trees can talk. And if you haven't, I highly recommend checking out the TED Talk by that name, Trees Talk. The first principle is living roots in the ground. Living roots in the ground with green growing plants on top for as long as possible, because as those green growing plants are growing, they are nurturing photosynthesis. We saw in Lauren's presentation how photosynthesis works and why that's a very important part of our energy budget from the sun. And when we think about back to the slide of degraded landscapes, all of those places in red are places where we are no longer nurturing photosynthesis, the life force that brings all life into the soil, that creates biomass, that cycles water, that cycles nutrients, and that sustains life. When I show this slide, I always like to point out the red circle is showing you your standard lawn grass. And when we think about the potential of root systems in our soil, as indicated by the other plants on this chart, these are plants from northwestern prairies. Many of them you may recognize if you're gardeners, like the lupin and the echinacea. Some of them are specific to to other regions and may not grow in Vermont, but we have similar plants here. And depending on our soil structure and the layer of bedrock where that lies underneath, we could have root systems that go all the way down to 15 feet. Lawns just don't provide that without diversity. We'll talk a little bit more about lawns later. Thinking about those root systems that we just saw going down as much as 15 feet, what we're looking at here is a really close-up view of what could happen around a root system. So the brown thing in the middle is a fine root hair. The blue area around that is indicating what we call a rhizosphere. That's an area that exists around root systems, all root systems everywhere. And as we learn more about soil microbiology and how these organisms work together, we're learning that that rhizosphere is much vaster than we thought because of the addition of mycorrhizal fungus, which is indicated by the white hairs growing in on the left and right into that area. Those are not actually roots, that is fungus. And that fungus helps plants to communicate and cycle nutrients through the soil system. The little red dots in there are indicating the billions of microorganisms that I mentioned a moment ago. Those microorganisms are fed sugars that are produced through photosynthesis from the sun and from green growing plants. And if we can continue to have green growing plants growing for as long as possible, then we're nurturing photosynthesis. We are feeding all of those organisms, creating the conditions for them to continue to proliferate, reproduce themselves, continue to cycle nutrients by producing the organic acids that they can, that dissolve sand, silt, and clay, the rock, to bring all those nutrients up to the plants themselves. This is how natural ecosystems eat. There's nobody going around with a bag of fertilizer in the forest, and the forest does really well without that. So in terms of lawns, thinking about that red circle and those tiny little root systems, that's typically what you're going to get in lawns, not only because of individual species being very few. Usually, even in a conservation mist, you might have a mix of grass seed, you might have rye, fescue, and clover, and that's certainly better than only one species. But how do we get more species into that lawn? Can we add more things? And can we pay attention to the plants that are growing in our lawn that nature is providing already there for us? I wasn't quite done there, sorry. We have more lawn just in the United States than we have many other crops in the ground. If we were to transform the way that we manage our personal lawns, we could make a big impact in the ability to cycle nutrients, increase biodiversity, increase carbon cycling, and increase water cycling, all of which will benefit all of us and all other beings on this planet. The second principle of maximize diversity, that's diversity of everything above, everything below, and as I'll get into a little later, even our diversity of thought. So maximizing diversity, I love this picture because it shows so much happening in just a square meter of soil. It's really incredible in a healthy landscape how many beings you can find evidence of in a small area if we simply pay attention and help to create the conditions that allow those organisms to thrive. Diversity begets diversity. Above the ground, below the ground, species, heights, textures, structure, color, timing, all of these things are important when we're thinking about our home gardens and our farm gardens and our public parks and our landscapes and our row crops and everything in between. The more diversity that we can get, the better. Timing of different flowers, different shapes of flowers, annual flowers, perennial flowers, grasses, forbs, which are basically any of the plants that aren't grasses. Lots and lots and lots of diversity, just like Mother Nature has shown us to do. Diversity below the ground is a pretty new thing to us. We don't, well, it's not new, it's just new to humans. We are just beginning to understand the dynamics of the soil food web. Soil scientists, the most amazing soil scientists that have inspired me, constantly remind me that we only know 5 to 20% of what we think there is to know about this dynamic soil food web system that feeds all of life. And one thing we do know about webs is that when you disturb one part, you disturb it all. We need all parts of our soil food web in order to function well, in order to cycle nutrients. This is just another picture to reiterate the magic of the underground. I could go on for hours and hours about this stuff. It's just so exciting to think that underneath our feet in healthy landscapes are everything that we need to be healthy and to encourage thriving ecosystems, to allow for thriving ecosystems. There's that pine picture again. I just think it's wonderful and I wanted to share it one more time. The third principle is minimizing disturbance or minimize disturbance. You can imagine if you think back to the pictures I've just showed of microbes and healthy soil activity and living roots underneath the ground, supporting all of these dynamic life forms in the rhizosphere. If we send a machine like this through the ground, what is that doing to all those little organisms? So excessive tilling, use of chemical pesticides and fertilizers, it kills soil life. Every time we disturb the soil, we disturb soil life. Disturbance, it is important to mention, happens naturally. We have volcanoes, we have floodings, we have all sorts of things that happen naturally. Disturbance is natural. Tilling, I'm not saying that tilling should never ever happen, but can we rethink the way that we do that so that we're not so damaging to entire ecosystems? The disturbance to insects because of chemical fertilizers and pesticides is outrageous. Of the 1 million insect species that have been identified on our planet, only 1% of those are known to be harmful to humans. And a sliver of those are actually agricultural pests. And yet we have managed to shrink the number and existence of insects. So we've shrunk the diversity of insects and the population quantities of insects everywhere around the globe. We're hearing this all over the place. And a lot of this has to do with the degradation of landscapes and the ways in which we degrade those landscapes. The downsides of conventional agriculture are many. And in terms of climate change, there's a very strong correlation between the way that we have managed our land globally for the past 150 years and even up to the last 8,000 years, but really the last 150 years, we've really managed to accelerate everything. So this slide is giving a little bit of an indication of the ways that we have disturbed things. The monarch butterfly is our sort of poster child, but that's just one of the 1 million insects that we know about. And it's a really beautiful one, but there are many others that are also critically important, that are very small, that we may never notice, that may be just as beautiful or not, but are just as important. One thing I really want to point out here is the idea that endocrine disruption is caused from continual degradation to the environment. And in this picture, it's showing pesticides. And this is something I think we all need to learn more about. How do we restore the human biome? How do we restore ecosystem biomes? And I think that we have the answers to be able to do that. And if we work together and listen well to our greatest teacher, Mother Earth, we will be able to do that. How we manage land affects carbon cycling. The top picture here is just a simple drawing showing you that when you have biomass on land, plants and animals, root masses, organisms, you have carbon cycling. Looking at those little dots, you can see on the left-hand side of the drawn picture that we have a lot more carbon cycling, a lot more carbon in the ground. And on the right side, where we have very few plants or very scraggly plants that are struggling, we have more carbon dioxide up in the air. So the carbon becomes a gas when it's not being held in life forms in biomass. On the bottom slide, that's a real life picture of a place in Karoo, South Africa. That's a famous fence line photo from the Savory Archives. That's the Allen Savory Archives. I highly recommend checking out his TED Talk that talks about holistic grazing and how that can really help to restore grasslands globally, cool the planet, cycle nutrients, and help all of us more to rehabilitate our degraded landscapes around the world. The only thing that is different on the left side of the fence as opposed to the right side of the fence on this picture is the way that animals were managed. This land looked like the right side of the picture for a very long time. You can imagine on a very hot day that if you were on the right side of the fence with bare feet, your feet would be scalding. The water is evaporating into the atmosphere. The carbon is leaving the ground and becoming carbon dioxide. There's nothing holding those cycles in. On the left side, we have carbon going in, we have water going in, and we can visually see the results of carbon and water being held in those landscapes in the form of plants. The only difference between these two sides of the fence is the way the animals were managed. On the right side, animals were allowed to roam largely, and they would eat only what they like. They would not cover the whole landscape. There's a lot to look into in terms of holistic grazing management, where on the left side, those practices were put in place. So holistic grazing management is, in a nutshell, replacing predators with fences. When we think about the buffalo or the wildebeest or how large herds have always moved around the earth, they stayed together in large groups. They would cause disturbance as they moved through. They would eat everything but not right down to the ground. They would leave poop and pee and bits of disturbance with their hooves, and then they would move on and not come back to that place until the landscape had regenerated. And they would stay in those herd structures very close together because predators would keep them that way. Since we, as a human race, have taken away most of the predators, we're now finding that if we can use the ruminants that we manage as humans and replace the predators with fences, we can get a lot of the same effect on landscapes. And this regeneration took about a decade, I believe, to change, and now it's holding steady like the left side of the fence. This is something that we can do everywhere. Keeping soil covered on every scale is really important. So again, this is the second principle, or the third principle, no bare soil, keep soil covered, mimic natural systems, implement polycultures, which are just systems that have lots of different plants that work really well together. Nature provides these selections of plants for us all the time. We can pay attention to nature to find out how we can replicate these polycultures in our own gardens. Using cover cropping is really important. Living green growing plants, covering bare soil, growing between trees like you see in the alley cropping picture, growing between the two piles of mulch is ryegrass on the bottom left. And on the bottom right, you see ryegrass growing in a cornfield. That picture was taken in the Connecticut River Valley. In Vermont, we do have some conservation programs that are helping farmers to afford cover cropping seeds so that they can cover their soil after the corn is harvested so that they don't continue to lose soil into the waterways and contribute to water quality issues. A lot of these solutions are happening. We need to ramp those up on every scale, from our backyards and gardens to our state parks and to our farmlands. We can rethink our urban spaces. We are starting to see more and more urban gardening, and that's really important. Some of it has to do with, yes, healthy soil and cycling carbon and cycling water, and some of it has to do with food security and food sovereignty, to have people have the ability to grow food near them. This is also aesthetically very pleasing. Air quality is improved when we have more plants. So there are lots of things that we can do. And I just want to point out the bottom left picture here is the rooftop at Fletcher Allen Hospital in Burlington, where they have a rooftop garden they've had for many years. And this particular hospital is also very focused on trying to make sure that a lot of local food comes into their cafeteria for their staff and their patients. It's an excellent example that I'd love to see spread all over the place. The fifth principle, animals in contact with the soil. So this is integrating animals into livestock systems, into natural systems. Nature always farms with animals. It doesn't matter if you're talking about microbes or chickens or humans or zebras or elephants or cows or pigs or sheep or rats. Nature always farms with animals, and there's a reason for that. And so we also should be listening and watching and mimicking that. And these small herds that you see, whether it's cows or chickens or pigs or sheep or whatever, this is all holistic grazing management, where we group animals together in larger density, stocking density than we might have thought was good. We use fences to keep them close together, and we move them often. It could be every 2 hours, every 12 hours, every 2 days, or every week, depending on lots of different ideals. So we are animals too. Humans are animals too. And I think it's really important for us to remember that in the context of this fifth principle. We need soil contact, and soil needs us. This is a cartoon drawn by my husband. Land regeneration can happen really quickly. This is a wonderful example, again, from the Savory Archives. This is in Zimbabwe, and I got this slide from my friend Seth Itzkan from Soil for Climate, who is one of the sponsors of this series. And he tells me that this is sheep and cattle country, but he suspects that it was actually the cattle that did most of the regeneration of this landscape. In 2004, on the top left, you can see that this landscape has been bare ground for decades. When a raindrop would hit that landscape, it would be like a bomb hitting the landscape. It would cause compaction. It would not soak in. It would evaporate right back out, and no water would be held. After just 1 year of using holistic grazing management practices in this landscape, annuals began to appear. The next year, with those same practices, we had a densely packed cover. And you can see in just 2 years, the way a raindrop would react in these landscapes is very different. And if you were walking on this ground with bare feet, the feeling of the heat on your feet would be very different from 2004 to 2006. Jump ahead 7 years with the same management practices, we now have deep-rooted perennials, and we have a thriving ecosystem that can manage water and carbon and provide food, not just for humans, for lots of beings. The sixth principle, slow and sink the water. Catch it, slow it, where it falls, infiltrate it in place, retain it in place. We have a habit as a species of taking rainwater and rushing it out to the ocean as quickly as we can, as if it's a problem and not a gift to be held in the soil sponge. We can learn how to redo that. This is a pretty famous slide. This is a rainfall simulator from the Natural Resources Conservation District or Conservation Service. These are available, by the way, in Vermont from the NRCS. They can bring them to your events. They can bring them to your schools if they were open. And we can learn a lot from these. And what we're looking at here are basically 5 cookie cutters of different types of land management, but the same kind of soil. So the same ratio of sand, silt, and clay in each one of those cookie cutter boxes with different land management on top. On the left side, we're looking at what I like to refer to as the soil health principles in place. We have living roots in the ground. We don't have bare soil. We have minimized disturbance. We have maximized diversity. I at least see a couple of different kinds of plants growing in there. And I'm assuming that it's a pasture, so there's animal contact with the soil, plus we know there are microbes and other critters there as well. And on the right side, we have very bare soil. There's nothing growing in it, and we're assuming that that's highly tilled soil. The jars underneath, the ones in back indicated by the green line infiltration back row of jars, is showing the water that infiltrates into the soil, just like we did in the flour and bread activity. The water infiltrated or soaked up into the soil sponge. That back row of jars is showing how much water would soak into the soil. The front jar of water is showing only runoff, how much soil we would actually lose in a rainstorm. And you can see that the bare soil all the way to the right, the color of the water in that front jar is very, very dark. It's full of soil. We had 100% runoff and 0 infiltration in the back jar. And on the left side, exactly the opposite. We had 100% infiltration into the back jar. The color of the water is fairly clear, and the front jar does not have any runoff. Schoolyard flooding in July, just like the climate and agriculture folks at UVM say, we're going to continue to get more rain, larger rains. If we do not allow for that water to soak into our sponge, we're just essentially sending it off to our ocean dead zones. That little map on the bottom right is showing a pretty recent map of ocean dead zones globally. There's a lot that we can do to change this in our culture, and it's up to every one of us to do that. I've been working with 6th graders at Thetford Elementary School for a number of years doing soil science, using protocols that were designed by Dee Dee Pershouse and Land and Leadership and the Soil Carbon Coalition to teach about soil science, water infiltration, a bit about soil microbiology and composting. These students are beginning to understand how we can better manage water in the landscape at school to be able to grow more food and get through drought periods without using too much water from our school system. The 6th graders at this school manage our compost. They make all the deposits, they monitor the compost, the data they collect is tied to their curriculum. 5th graders turn the compost, and the finished compost becomes a place where we can grow lots of pumpkins at our school because we grow more compost than we have gardens for it. So I'm getting to my closing now, and I think I've done a pretty good run through of the soil health principles. I'd love to get more into that in our question and answer session. And I just want to leave you with some ideas here that soil health and soul health are the same. If we're not taking care of our soil and we're not taking care of our souls, we're going to have a hard time moving forward through these challenging times. So I would like to ask you all to think about what are your soil health principles and how can we embody the soil health principles to determine the practices by which we are going to interface with land on this planet, and how can we implement our soil health principles so that we can inform ourselves a better practice of how we interact with one another, all beings, not just humans. As we get into our discussion period, I would like to encourage everyone to think about asking better questions. Reflect thinking on whole systems. The image on the right here is the elephant in the room. This was designed by Peter Donovan, one of my colleagues and mentors from the Soil Carbon Coalition. And I think it's self-explanatory, but just in case, I'll just say, you know, we could focus a lot on disease. We could focus a lot on scarcity conflicts and climate change and weeds and which plant is better to do this and which one is better to do that and how do I do this very specific thing. And all of those may be very important questions. But until we look at the whole system of climate change, the whole system of how Earth works, the whole system of how humans interact with one another and in what relation we live with the land, we're never going to get to be where we need to be. So let us think in whole systems. Let us not allow ourselves to get stuck by bad questions. Let's ask better questions and let's help each other to learn how to do that. We have lots of opportunities ahead of us. If we work together, which we are, we're building that social mycelium. It's strengthening every day. I'm so grateful to be a part of it. And I know that we can do this. We can adapt, we can change our behaviors. We can live in alignment with natural systems. We can make the fundamental changes from social culture to agriculture to address and mitigate climate change as a whole systems challenge. We can live in right relation to the land. Humans can allow for the rehabilitation of global land surfaces and the liberation of all living beings. We can do a lot by the way we grow food. We can do a lot by the way we support our community. And we can do a lot by the eating choices that we make. Thank you very much.
Thanks, Kat. So we are going to have myself, again, Lauren Weston, and then Nancy from Vital Communities, and Kat. Nancy, your microphone is still muted. I don't know if that's a Bob thing or a Nancy thing.
I got it, thank you.
So we're going to take some questions, and then we'll move into the rooms soon, and we'll do some group discussions. So if you need to go to the bathroom or get up and stretch your legs, now would be a great time to do that, but please come back for the discussion piece afterwards. So Nancy is going to be asking questions to myself and to Kat based on what came through the chat. And if you have more questions, please continue to add those to the chat and we will respond the best that we can. And thank you so much.
Super. Thank you, Kat, and thank you, Lauren. So I'm Nancy from Vital Communities, and I am just kind of facilitating the chat questions for Kat and Lauren. So there haven't been a ton of them, but if you have some, please add them to the chat now. I'm looking at it and I'm trying to collect them into similar questions, but I'll be relaying them. And so I do have a couple that I'll share now. Lauren, we didn't get to ask you any questions after your presentation. So there is, Lauren, given your understanding of how local climate will likely be changing, what trees and crops do you think will be more viable in this area, and which ones that we currently enjoy will be less viable down the road?
Great question. I think what I would like to respond with is that we need to maximize diversity, as what Kat was saying, is that we need to make sure that we have lots of different options to pull from, because we don't exactly know what's going to be happening. At this point in time, we think that Vermont is going to be more extreme, drier, and also have longer periods between really heavy rainfalls. So obviously drought-resistant trees and crops would be great. I don't have any specifics off the top of my head, unfortunately, but happy to look some of those up and share those later. But I think just really making sure that we have a wide diversity and that we have the conditions, like Kat was talking about, for any of those to thrive. Nature's pretty good at fixing itself in terms of knowing what it needs. And so that is what I would say for that question. I think Kat might be able to add something to that as well.
Kat?
Yeah, I can add a little bit to that. I don't like to suggest specific species because I think every landscape is different and every person's needs are different. When I'm choosing species, I always try to choose native species first, species that are, as Lauren mentioned, drought resistance or perhaps resistant to large amounts of rain or resulting funguses, mildews, and molds that may occur with larger rainfalls and more moisture in our environment. And I highly recommend keeping a journal. So when you plant something, write, how is it doing? Because even based on what we think we know about our region is changing and plants are adapting more quickly than we can. I would also suggest that we ask the plants and let's listen to the plants. And I just want to point out it's a tricky topic for a lot of people, but invasive plants. Let's ask them why they're here. Let's find out what we can do. And I'll just mention knotweed as one of those. Japanese knotweed is something that people are freaking out about. And I understand it's changing environments, but it also contains the medicine for Lyme disease. It's helping to hold some of our riverbanks together, but maybe not as well in all places. It can break apart, and part of the way it moved around was Hurricane Irene. So I just want to encourage us all to be really mindful of who else lives here. And the plants that we're planting aren't just for us. When we choose native species, Doug Talamy is a great resource. You can check him out. You can Google him. He has lists of native plants and all of the species that rely on those for habitat and food. So that's a really important consideration when choosing plants and also food for us. So be thinking about that. There are a lot of really incredible permaculture designers in our state that we can tap into for that information.
And I'm guessing some of those resources would be on the Healthy Soil Coalition website, Kat, if people want.
Yes, we'll get them up there. And I just saw in the chat, I'll write Doug Talamy in the chat.
Great, super. And so Lauren, another question from your presentation is, can you define watts per square meter? I'm guessing that.
Yeah, so it was, I think I kind of answered it a bit earlier, but the WM2 is just watts per square meter. That is not formatted very well on the screen.
Okay.
And so that's energy per surface area is what that is.
Super. Kat, is there any science yet of the impact of rising soil temperatures on the earth temperatures on the soil, microbiome, and rhizospheres?
That's a really interesting question, and I don't know what's been done in terms of data collection and all of that, but certainly in terms of soil degradation and increased desertification, so we know very clearly that a desert is a lot hotter than a place that has a biodiverse ecosystem. And if you think just of Syria, that used to be a really biodiverse ecosystem and is now a desert, we can know that temperature has changed. But in terms of the data, I'm not too sure. And I would invite, I know Dee Dee Purshouse is on the call and Lauren is an incredible researcher too. So one of them may have a better answer to that question.
Can you repeat the question? This is Dee Dee.
Yep, sure. Is there any science yet of the impact of rising earth temperatures on the soil microbiome, rhizospheres?
So one thing I do know is that soil microbes definitely. I mean, what we see as desertification is essentially a lot of that. That when the soil is bare, the temperature heats up enormously. Kat probably the slide. I don't know if you can pull it up quickly of the temperature difference between covered soil and bare soils on a like an 80-degree day. But we're getting soil temperatures that are, you can think about it of like what it's like to stand on a dark bare surface versus a grassy surface, and those are temperatures that are not conducive to life continuing. So in terms of research, I'm sure there is research out there. There's research on just about everything in the world, whether anyone's reading it or not. Half of all research papers are never read by anyone other than the writer and the editor. But absolutely, when we see soil turning from a sponge into into dirt or flour, that's an issue. So I'm looking, Margaret saying she means in covered soils. That's a different, that's a different question. And I think there is some research that I've seen around there's a project called the Global Soil Biodiversity Network, I believe. And they are looking, I think, some at changes in the microbiome, not necessarily loss directly, which is, so those are two slightly different questions.
Great. Thanks, Edie.
Lauren, did you have something to add to that?
I do not. Thanks, though.
Great. So there was a question of, can we get access to CAT's curriculum for school curriculum? And I think that will be on your website also, Kat. Can we make sure that that ends up on the Healthy Soil Coalition, or?
So the thing there is that I'm working with the students constantly and haven't actually written much down, but I am using Dee Pursehouse's manual, Understanding Soil Health and Watershed Function, as my base, and I'm modifying that for K through 6. So her manual is available, and I think Dee already put that in the chat, and it is up on the Vermont Healthy Soils Coalition website. It's an incredible manual. I use it all the time. I get incredible ideas from it, and Dee welcomes all of that. That's what it's for. So that curriculum is available, and when we do get to the point of writing our curriculum, which everything has changed now because our teachers are a little busy these days, we will absolutely be sharing all of that. Absolutely.
Great. We only have a minute or two left, so let me see here. How can we encourage more rooftop gardening? Would it be zoning changes, incentives? Are there any nonprofits working to facilitate this?
I would agree with the idea of zoning changes, and I know that in the next event we will be having someone from Vermont Law School who's going to be talking about zoning and kind of that idea. Some of the other things to facilitate this is just really getting people to understand that, like, there are surfaces that we can be using, making sure that you are aware of your structural needs for your house and your roof, and so you're not putting things at risk. But I think, again, a lot of it's just education and making sure that people have the resources they need to do the things that need to be done.
Yeah, and I'll just add to that, that in addition to gardening on rooftops, you know, rethinking the way that we're collecting rooftops, the way that we're designing them, collecting water off of rooftops, these are important. So these are highly reflective surfaces. How can we change that surface, and how can we modify our behavior around those surfaces to actually collect, slow, and infiltrate water?
Right.
Excellent.
Thank you all so much. This has been really interesting and informative, and learning technology is not something that I thought I was going to be doing right now, but you're all worth it. So thanks for giving us the opportunity to want to do that. Everything that we did today is going to be available on recording. We're going to have to do a little manipulation to put all the pieces together. Hopefully we all remembered to hit record in our little checkout or little breakout rooms. So in closing, I want to say thank you, thank you, thank you. We have more events coming up. Please plan to attend them all. We have increased our license abilities, so we now can hold a lot of people, and hopefully we'll get better at breakout rooms so that we can make that part of the event more rich and useful to everyone. You can check the Vermont Healthy Soils Coalition website for all of the upcoming dates. Please also stay tuned should anything change. We will be letting you know there. We are working on the ability to live stream future events, so stay tuned to that. I know we can connect with Facebook and YouTube, and we're learning about how to do that. Much thanks to Bob Farnham, who is amazing, and we're so grateful that he showed up to help us. If you have registered for our events, you will receive emails with any updates. If you did not specifically register, you might consider doing that, or like I said, just keep checking the Vermont Healthy Soils Coalition website. And before I end, I just want to thank again all of our incredible organizing team. We learned a lot just about working together to how to make this happen. The rest of our presentations are going to be amazing. Lauren Weston has done all the work to pull the speakers together. So stay tuned for that. And again, I also want to thank all of our sponsors who are just incredible. And remember to buy your Chelsea Green books with a 35% discount. And please donate to our series if you can.
And just so you know, the next event, we will have Chief Nathan Pirro as our speaker, in addition to Whitney Shields from the Vermont Law School Center for Agriculture and Farming. So please join us then to hear some different voices besides Kat and I's lovely, lovely voices.
Wonderful. And Kat, can you give us the code for Chelsea Green once again?
Yes, the code for Chelsea Green, if I could read it.
BALE 35, BALE 35.
There we go.
And you can also get that on the Vermont Healthy Soils Coalition website.
Thanks, everybody.
Thanks, everyone. See you next time.